Okay, thanks very much. What I wanted to talk about today was basically data warehousing, big data analytics, and how they fit together, where the convergences are, and how data warehousing needs to evolve in order to be able to function with big data and bring about a synergy that is effective and useful for businesses. So what I'd like to talk about are the imperatives that brought this about, the types of data value chains that we're looking at in terms of big data warehousing, analytics, the types of things that we can put in place in terms of the overall architecture and components, modules within that architecture to bring about the effects that we want to achieve. And I want to talk a little bit about what I've termed information supply framework or data supply framework. I've used that term rather than call it the thing. So it's pretty much talking about traditional data warehousing, how's that evolved, how it's become in a certain way corrupted, so we have a misunderstanding about what data warehousing was supposed to be, and therefore it just gives us a wrong idea maybe about how it should evolve together with big data or to be replaced by big data. The hashtag, as you know, is hash BDS15. So I'll proceed to the next piece. Just a bit to explain where I'm coming from. It's Karl Marx, but it's applicable to a lot of areas. My experience is in big vendors, big traditional corporations, big traditional data processing. So my views tend to be tempered by my background. I'm not from a web background. I'm not from a big data background. I am from a VLDB background. I am from a HPC background, but not from a conventional big data background. So I'm looking at ways to converge the areas that I know specifically about in detail with the things that are new now in terms of, especially related to web developments, web-based applications, social media, and so on, which hasn't been the traditional domain of the traditional companies until fairly recently. Also wanted to talk about, just to say where I'm coming from in terms of my understanding of big data and the relationship that we have with big data and I guess the hullabaloo, the hype, a lot of the hype surrounding big data. The opinion is that there's a lot of good stuff there, but it occasionally gets drowned in a lot of the hype that also accompanied data warehousing in its time. So looking at moving from, the situation that we had in the past of very little data or some data through to a situation where we have a lot of data in order to be able to help us to understand where we are, where we've been, and where we want to go, and to effectively change, to bring about change, because if we're not using data in a strategic way to bring about change, then we may as well not bother. So that we're basically looking at where we can obtain data from, and how to integrate that data, how to analyze that data, how to present that data so it brings about change. The key to the success of the big data, of course, is the well-architected and managed integration of big data into mainstream strategic, tactical, and operational analytics and decision support. And we're going from business, of course, again, just to emphasize business data warehousing, big data, statistics, and presentation. But again, to support strategic, tactical, and operational aspects of the business. My perspective is that it everything we do needs to be driven by a business imperative. We don't do things in the area I'm talking about it because it's interesting or it's speculative. There's got to be a reason to do it, a concrete reason. And starting off with the obvious reasons why people are in business, or what's important to the people in business. And of course, it's a couple of things. It's been noticed and control the cash flow. And then everything after that is additional. And these are some of the additional aspects, but I won't dwell on them too long because I'm sure everybody is aware of them. Okay. So why do we need data in a strategic, tactical, and operational sense? For example, we in order to address strategic challenges to an organization, we can come up with various models of how we model what is there, model the challenge, and so on and so forth. But each and every one of these models requires adequate, appropriate, and timely information. Whether we're looking at the competitive forces in the market, the framework of understanding our own organization so that we understand, okay, we want to go forward with these strategic options, but are we in a position to be able to support those strategies as responses to significant challenges, not just as things that are nice to do. And then we're looking at our differential capabilities because everybody wants to be different, even though we're operating in the same markets. Again, we can either take that approach or in other markets understand that we are very similar to other companies, and the differentiator is to be better at what we do within that market. And it helps us, again, we need data in order to construct relevant, appropriate, adequate operating models in order to support the business. So it all comes back to where we get this data from, what we do with it in order to structure it, to integrate it, to transform it, to present it in a way that is usable to the people within the organization who need to use it. So we have information awareness corresponding to the areas of interest and control, and basically the objective now is to identify the framework which allows us to continually seek to maintain and then improve data's contribution to business. Basically, business data is everywhere. Internal systems, external, shared environments. Data represents the past, the present, and the future. We have operational data now, big data, dark data, online data, archive data, and unmanaged data. A lot of data is, in fact, unmanaged. We can find data in archives, documents, media, business applications, so on and so forth. People will be familiar with all of these things because, excuse me, apart from public web and social media, a lot of this data has been around for a very long time. We talk about sensor data as if it was a new thing. It's not new. It goes back to the 1950s. Bell Laboratories were doing signal processing, even in the 50s. And if you could look at the Bell Laboratory journals, it will tell you a lot about signal processing and continuous processing. What there wasn't there were the platforms in order to be able to do it on a massive scale. But a lot of the upfront work was done there. Every presentation should have a triangle, and this is the one in this presentation. It basically represents how we want to or think we can move from data through to information and knowledge, depending on how we're putting data in context, how we're transforming information into knowledge, also based on our ability to uncover and understand and use data and information and the structured content, the context of that information and data, and whether that data is prepared for strategic or tactical or operational use. A lot of facets of data that, oops. Okay. But there's a lot about data, and talked about these days. A lot of it is very confusing. At a high level, it all sounds very compelling, and especially when it comes to big data, it's the idea is that if we're not on board with big data, somehow we're going to get lost as businesses, as organizations, and people within those organizations. So that we're constantly bombarded with information regarding big data, the Internet of Things, the cloud, the statistics in some form or another, although a lot of people prefer to call it data science these days, or data analytics, or predictive analytics, and so on and so forth. Data warehousing, again, is there, but to a much less extent than before, because in part it has a bad reputation, because a lot of projects that were billed as data warehousing projects have actually failed. We'll come to that now, and we're looking at the presentation layers for data. And underpinning this, what I want to talk about is the data supply framework, which would help to bring together a lot of the good ideas coming from various areas and disciplines into one cohesive whole that is simple to explain and fairly straightforward to implement. So basically, I'll recap on what is data warehousing, because I want to come to another point, which is a misunderstanding of what data warehousing actually is. And it represents 25 years of getting things right some of the time. And I'll start off with a description of, as we all know, what data warehousing is, the characteristics of data warehousing, subject-oriented, in talking about customers, products, arrangements, and so on within an organization, with suppliers, with other competitive forces within the market. The data in a data warehouse is integrated, fully integrated. It's time variant, so we can take a look at the data from different points in time. So I can look at data from in the past, from now, from the perspective of now, or can look at that same period from the perspective of a period prior to that point, which gives us a complete understanding of the data throughout these periods from different points of view. And in the past, we said, okay, data warehousing is specifically for strategic decision support. It has to be non-volatile, so we don't want things changing all the time. So when we come to putting together strategic responses to significant challenges, we're not building on moving sands. So that's basically what underpins it. Initially, this was about strategic decision-making. It wasn't about producing operational reports. And this is just underpinning what I've just stated. The important element of this, again, is the strategic support element. I know data warehousing is used for many other things, such as operational reporting, but that's almost like something that ancillary to its prime objective, and something that came along later as an additional way to use what was being built. So this is a diagram of an old-fashioned data warehouse platform. You see you're going from internal and stage data through the operational data store, enterprise data warehousing, to data marts, to reports and extracts, and underpinning that we have metadata and process and infrastructure EDW management. So that's the old-fashioned Bill Inman's data warehouse. 25 years of sometimes getting it right and wrong. A lot of data warehouses is simply based on getting data, dumping data somewhere else, querying the data, visualizing the data. And we wonder why it doesn't achieve the benefits of the Inman or the Kimball type data warehouse that are previously described. And this leads us to believe that this type of data warehouse, wrongly identified as a data warehouse, but just basically a place to dump data, can also be achieved by using different technologies. This is also a mistake, because we have a situation where we created something using legacy technologies or the older technologies from relational, and think we can replicate that using newer technologies. And in fact, we can do that, but we're actually building the wrong thing, regardless of what technologies we're using. And that's why Bill Inman packed his bags and went off somewhere else. So in order to understand where we're going with the data supply framework and how this will impact the success or not of big data in mainstream business, that is, we need to understand what we have in terms of the data, source data, because we have a huge variety of data sources. And we have a huge capability to process this data in almost any way we can think of, using the methods and technologies that are available now and are coming along in order to provide both better performance, maintainability, ease of use, and so on and so forth, in order to provide all the information that is required and all data to the consumers who need it. So this is a simplified view of a data supply framework that includes big data, especially in terms of analytics, data store, and the statistical analysis we can do with the data within that store. Again, emphasizing a lot of the internal and external nature of the data. For a lot of the strategic decision making, we're still going to be looking at operational data, which is highly structured. And to complement that, we're looking at getting data from social media, from the internet, from our applications that are based on the web and the web use, and being able to bring that in and complement our operational data with that additional operational data, but it's seen as in a different perspective. This again is a more detailed diagram of a data supply framework. It details, for example, the next generation of data warehousing in terms of the integration with analytics data store, and our ability to not only analyze and identify the pieces of information that are valuable, but able to write that back into the process as if it were, again, a source system for data, and then have that populate through the whole of the data supply framework, and including in the fourth generation data warehousing environment, so that we're complementing data warehouse data with data that's coming from, I guess, non-traditional sources, I guess in my terms, but in terms of big data, it's the conventional big data sources of data. So again, looking at data sources, to emphasize, most data is highly structured. It comes from operational systems, but we can use a lot of data that's coming from big data sources in order to complement what we have there. Again, there's a growing collection of tools for capturing and transforming this data, but the point is, again, as emphasized here, we need, in all of this scenario, we need to understand that the closer that our data is to the money, the more value that data will have. The more closer that data is to transactions, money in the bank, and sales, the greater the potential value, as always. So to contrast the next generation of data warehousing with the previous, a lot of it is similar, but there are new rules. Subject orientation is, of course, key to structuring the data so that it's both usable and it can be integrated very easily. The time variance aspect still persists, but there's an enhanced form of how we can move through time to understand what has happened and to project what will happen based on our understanding from now, but also from the past. I know that, it's in the past we talked about non-volatility within a data warehousing environment, but because we're nearly now looking at data warehousing to support a huge variety of data requirements within an organization, from strategic, tactical to operations, then the constraints on volatility can only be applied to certain areas within that framework, particularly when it comes to strategic decision support. But these are things that are, again, they all have differing time windows, and for strategic decision support, it doesn't matter if the data doesn't change from one day to the next. I mean, we're not going to have continuous input of strategic challenges day on day on. So the strategic challenges don't come in thick and fast to that degree. So that for that, we can basically go with what we already have in terms of the current support from data warehousing. But in terms of tactical and operational decision making and how we reconfigure at operational level, yes, that has to be almost continuous in terms of how we ingest data, how that data is rapidly analyzed, and how that then is populated through to basically to give access to that newly derived information to the operational systems, and of course web applications being also a part of the operational systems. And again, to emphasize, it's not only strategic, it's strategic, tactical, and operational support that we're looking at. Again, addressing a number of areas within the organization, from interpretation through prediction, diagnosis, to instruction, repairing, and control. That's the aim of having this type of infrastructure in place, process in place, so that we basically start beginning to address more data. It's not all data, of course, although we'd like to think it's all data. It's a lot of data in terms of the operations and the environment. But we'll come to all data at some point in the future. It's probably going to be a long time yet before we can truly say that we have a 360-degree view of anything. But we're advancing, and we're advancing, of course, more rapidly all the time. So using this to apply and measure data we're dealing with. This is basically just a value chain in terms of what we're doing with big data and how it, again, we take the outcomes of the analysis of selection analysis of big data, and then we bring it into a data warehouse in terms of, okay, regarding dimensions, regarding measures within that data warehousing environment. So we can use that then to design campaigns. We do one-to-one marketing, market segmentation at any level of abstraction we want, and then we can feed that back into the process to analyze, did we get it right? Is there anything we can improve? What should we leave out next time, or what should we try next time in terms of analysis and how we apply it? Again, this is just to emphasize, it should be with data warehousing, traditional data warehousing, it should provide us the ability to go to any point in time and see things as people saw them at that point, or to see things from today back to the past, or to see things, to look into the future and to guess what, project what we think might happen based on the data that is given, and of course the interpretation that is provided as well, because data on its own without human interpretation can be a little bit fickle as well. So what I want to do is combining big data analytics with data warehousing in order to both support the idea of strategic, tactical, and operational support from data warehousing, but also to bring data warehousing closer to the mainstream, as it were. Because in terms of businesses, it's close to this part of the organization that deals with web applications, with social media, and so on and so forth. But there's, in a lot of places that I've encountered, there's still some distance between, okay, the traditional operational side of things, the data warehousing side of things, and what big data is doing. And there's, I would say, a huge degree of misunderstanding on both sides of what each and everyone is doing. And therefore, it's becoming difficult to get the best from both. Because we need to understand organizations are getting more web-enabled, that they're out there in the markets, on the internet, analyzing social media feeds and all the rest of it, and internet logs in order to understand what is going on there, to put together campaigns, to measure campaigns. But in order to measure it successfully, we also need to have something that is built to understand what the plans are and how to measure their success or not, so that we know in future it's not just a question of thinking, well, it seemed that though the campaign worked successfully, but we're not 100% sure. Whereas this something more in this way should theoretically provide a better basis on evaluating what has been done, the analysis that's been done, the conclusions that were drawn, and how that was applied to the business, how that was affecting strategy and tactics. So just a brief look at the statistics part of this data supply framework. Apologies for the color coordination here. The analytics data store and the statistical analysis and the scenario aspects. I'm just going to go quickly through these slides because they were running out of time. Okay. So this is the core statistics part, and basically it's designed using the conventional data flow approach and looking at being able to support the ingestion of complex data, event data, and infrastructure data. But typically what we're looking at is data that's coming from internet logs and social media at the moment. But that in fact will be opened up, because although we have had the capability of high-performance computing with regards to processing sensor data, we're doing now in much greater volumes and much greater speed than was previously the case. And this type of platform will also be able to, can support that type of processing. We know because similar platforms have been used in the past for over the last 25 years or so. And what has changed is the technologies that we can use for storing. We have different approach now for distributed file systems. We had distributed file systems for a very long time, but we can do that, all that good stuff, much more cheaply, much more effectively than before, especially cheaply. So we can build an analytics data store that is encompassing a number of different ways of representing data, of storing data, of retrieving data, of comparing data, and so on. So, yeah, just to go, I mean, looking at the complex data just from and structured or highly complexly structured data contained in documents and other complex data artifacts, such as multimedia documents. There isn't I don't see such a huge demand right now for that sort of thing in the mainstream of business computing. But there is interest with respect to, certainly with respect to what is termed unstructured data and the areas of things like textual data analysis. There is Bill Inman, of course, the father of data warehousing, is now concentrating on development of tools for textual ETL, so extracting meaning from what he calls unstructured data, but in fact, you could call it unstructured or highly structured data in documents, for example, legal documents and contracts and so on, in order to be able to bring that into a more structured environment, which is more amenable to analysis and to statistical analysis. So looking at event data, for example, enterprise process data, a lot of business models now are based on the business process models, which as well as providing the application support, collects a lot of data with respect to the operations of the business and where things are within various business processes, their relationship with each other, so we can measure, effectively measure the performance of the organization in terms of the process from the business process data that we can ingest into the analytical data store. Again, infrastructure data, signal data, it depends on the type of business that we have. For example, Infineon do a lot of tests on integrated circuits, producing a lot of data continuously. That again is through the appliance of appliances based on at the point of testing. That data then can be streamed through very effectively through to again analytics, in order to be, for example, in their case, to identify problems with the manufacturing process early, because each minute of before production is stopped on a bad production batch, it costs a lot of money, of course. Event appliances, again, this puts dynamic data collection, selection and reduction functionalities close to the point of event data generation as physically possible. This is something else within the framework. And it really concerns the philosophy of, when it comes to big data, of reduce early, reduce often. So we will be getting in continuously increasing volumes, varieties, and velocities of data. So it's important to discriminate in order to ensure that the data that we actually pull through the whole chain is actually data that is going to be of some use along the line, and to basically based on a strategy of data by exclusion or by exception, so that we're getting data that we know that will be of some interest or value along the chain, and we don't take everything through to the final stages of analysis, because it's not really relevant. Signal appliance, again, this is very much future, because in respect to this architecture, because it's a lot of it is now being supported by other means, but in the future it can be brought into this environment, and it can be used to augment data within this environment. Again, we're looking at distributed inter-process communication, different forms of messaging, allowing higher volumes to be transmitted in near real time. Because there's always going to be issues of latency. Doesn't matter how much we put in terms of hardware and infrastructure and software, there's always going to be latency, and especially with the volumes that we're dealing with. Looking at staging and reduction, again, staging of data from these various sources. Many times it's easy to handle. The reduction and initial selection of data in staging, and you could say it's traditional data staging combined with more inline rule-based type of data reduction. So we're not looking at not only the simple way of reducing data as before, but more rule-based, again, with things like watermarks, but not watermarks in the sense of a physical watermark on a boat, but rules describing how events are triggered. So we can get data coming in. Some may be interest, some may not. One thing may trigger monitoring of an event, and then depending on what happens after that, we can pass that information through or highlight that information or that data. The analytic data store within this environment, basically statistics-oriented, analytics-oriented, data science-oriented, by focus area rather than by the way that data is traditionally organized within the data warehouse. Subject orientation, it's very much by focus area orientation, because we get a good mix of different aspects within, for example, one data set, whereas we would not normally get that in a data warehouse. And variable volatility and reliability of the data as well. And the fourth aspect is the time variance, which is, of course, much more difficult to manage in this structured environment, but fortunately we have the technologies to be able to manage that in a way that is satisfactory at the moment. Statistical analysis, this is I guess the data science part, where we're looking at things like the qualitative analysis, the diagnostic analysis, the predictive analysis, speculative analysis, data mining, data exploration, and modeling, all the stuff that we're very familiar with. A lot of it's been around for a very long time. Qualitative analysis probably goes back to the 50s. My first boss in IT talked to me a lot about it. So it's not particularly new in fundamental terms. What we've done is basically it's evolved over time. But fortunately, it's been around for a long time, and we've been able to evolve. And then we produce at the end of all this the scenarios and outcomes from all of this analysis, which then can be used to write back to for example, the analytics data store. And from the analytics data store, we can take it up to, for example, select from the analytics data store as a source for the enterprise data warehouse, which then feeds into to other areas of the business, such as strategic, tactical, and operational areas in a more traditional sense. This is just a rough description of the things that can fit in within the analytics data store, such as document database management systems, graph database management systems, semantic network databases, key value. Basically, whatever there is, we should be able to integrate it into this environment. We know how to do complex systems integration now. This isn't so complex. To build something like this should be fairly straightforward on commodity platforms and additional platforms that support the more high-speed in-memory type processing, for example, the XSL column-oriented analytics database platform, and things like MapR and Luster, and basically all of those things plus a lot more. Just got a couple of minutes now. Wanted to conclude. What are the advantages of this approach? It gives us, we can bring all the data into one coherent framework, and we can take a look at that data. We can predict what will happen in the future, look at what happened in the past, not only from today, but we can go back and say, what was that person looking at in the past? when they took the decision that they did, and a couple of days later, this is what they did, and this was the effect. So it provides a much more comprehensive analytics platform and ability to look at now, look back, and look forward with much greater ease. And of course, just a couple of, I wanted to end with a couple of comments, in terms of this type of approach. Never open up too many data fronts at the same time. Iterate, use Agile when it makes sense, keep everything as close to the business as possible, involve the business continuously, consider everything, but of course question everything. I think it was mentioned before that a lot of banking is based on trust. It is up to a certain point, but a lot of it's based on questioning that trust and on doing what is legal but expedient. Never stop hypothesizing, never stop testing our hypotheses. And certainly from this perspective, I think, and from the data warehousing perspective as well, every initiative must have a business imperative behind it. It's not a good idea to speculate without a business, although we've done it a lot in the past, it usually ends in failure. That's basically what I wanted to say very, very quickly. Thanks very much.